Hello friends, welcome to CS Digest. Now continuing with our topic of finite automata. In this particular video we will study about how we can represent our finite automata. Okay. So firstly it can be represented using a transition diagram. Okay. So what is a transition diagram? For example, we have three states. We studied what is Q. Q is non-empty finite set of states. So finite is Q0, Q1, Q2. So we have finite set of states. Okay. Then sigma that is input symbols. We are taking input symbols as 0 and 1. Here Q0 is initial state and Q2 we will take as final state. So let's draw a DFA using these tuples. Okay. So always initial state started with this arrow, that is Q0. So on Q0, Q1 and our final state Q2. Okay. So on 1, input symbol 1, let it remain on the same state, that is Q0. On 0 it will move to Q1. Q1 on 1 will go to Q2. Q1 on 0 will go back to Q0 and Q2 on 0 will go back to Q2, on 1 will go back to Q1 and on 0 it will remain in Q2. So this is just a random DFA. It has no meaning, but just to explain how a transition diagram looks like, how on different input symbols it can move to different states. So this is how a finite automata can be represented using transition diagram. Secondly, we can represent our finite automata using transition table. Okay, using the same scenario as we discussed in our previous diagram, we will have present state and we will have next state. On next state, how will we move? Either from 0 or either from 1. And so Q0 is our initial state, represented using an arrow. So Q0 on 0, see here, Q0 on 0 is moving to Q1. Q0 on 1 is remaining at Q0. Now Q1. Q1 on 0 is going to Q0. Q1 on 1 is going to Q2. That is our final state. We can represent it as a circle. And Q2, let's not represent here, let's represent only here because it will again become tedious. So Q2 on 0 is remaining on Q2 itself, and on 1 it is going back to Q1. So this is how we can represent our finite automata using transition table. That's very simple. Okay, now the third, which is not very commonly used, but for the sake of learning we can represent it using 5 tuple scenario. Okay, so here for example we denote as M. So in M we have what we have Q, we have sigma, we have delta, we have Q0, we have F. You should remember all these. Okay, so what is Q here? Q here is Q0, Q1, Q2. Okay, what is sigma? 0 and 1 input symbols. What is delta? delta we will write it as it is. What is q naught? That is initial state. Our initial state is q naught. What is our final state? Our final state is q2. So this is how we can represent using 5 tuple. So using this delta, the transition function, we can write it as q0 on 0, it will go on q1. We can see from the table itself, q0 on 0 will go to q1, q0 on 1 will go to q0, q1 on 0 will go to q0, q1 on 1 will go to q2, and so on. Okay, so this is how we can represent our finite automata, that is using our transition diagram, using transition table, and using 5 tuples. So that's about the representation of finite automata. Now coming on to applications of finite automata. Applications of finite automata. Okay, so this is frequently asked in our university exams also. So first application can be, it is used in lexical analysis of compiler design. Okay, lexical analysis you will study in compiler design subject. So this can be used in lexical analysis of compiler design. Second application is, it is used in designing the combinational and sequential circuits. It is also used in designing circuits. How? Using Mealy and More machines, which we will study in our next videos. Using Mealy and More machines. This you will understand in our next videos. Okay. One of the application is, it is used in text editors. Okay. And one can be, for example, in implementation of spell checker softwares. Okay, where we check whether a spelling of a word is correct or not. So it can be used in there also. So these are all the applications of finite automata. So from next video we will start designing our finite automatas using DFAs or NFAs. Thank you.